On the 16th of November 2022, we bore witness to the launch of the Space Launch System carrying Orion and a dozen or so CubeSats for Artemis I. The goal here is primarily to test Orion and the mission profile for upcoming Artemis missions. I will not tell you about any of that though, as many others have already done so. Instead, I will tell you about the Japanese side to the Artemis program. But first, let's start with Artemis I. The CubeSats carried by SLS are provided by a variety of universities and organizations, and two of these were provided by JAXA, OMOTENASHI and EQUULEUS. The first of these, OMOTENASHI, stands for Outstanding Moon Exploration Technologies Demonstrated by Nano Semi-Hard Impactor. OMOTENASHI is also Japanese for hospitality, one of the slogans for the 2021 Tokyo Olympics. Of course, nothing says hospitality like smashing into the ground at 180 km per hour. The CubeSat will use a small solid rocket motor to decelerate before hitting the ground. They'll then use a small airbag to deploy a very small surface probe on the moon, which is primarily equipped with an accelerometer. Or at least, that's the plan. The satellite is currently not under control, though attempts to regain control are still underway. JAXA's second CubeSat, which is faring a lot better, is mostly a science mission. EQUULEUS, or Equilibrium Lunar Earth Point 6U spacecraft, is named after the second smallest constellation in the sky, the smallest being the Southern Cross, which, if you've been around for, like 5 years, you've definitely seen at least once. The stars in this constellation are also really dim. None of them are visible from where I live, which makes it the least important constellation in the sky. EQUULEUS is definitely not the least important CubeSat though. EQUULEUS is a true successor to Titan, testing orbital maneuvers, including some lunar flybys, after which it will be stationed at a Lagrange point, all the while measuring dust in cislunar space. In doing all this, it will be propelled by Aquarius, short for Aqua Resistojet Propulsion System. A resistojet water thruster works by boiling water using electricity and using the resulting high pressure steam to propel the spacecraft. The CubeSat bears 3 scientific instruments: Delphinus, or detection camera for lunar impact phenomena in 6U spacecraft. This camera will be used to look for impact flashes, and in earlier parts of the mission, also to look for near-Earth asteroids or mini-moons. And, if fuel constraints allow, the spacecraft will attempt a flyby of such an object. Phoenix, the plasmaspheric helium-ion observation by Enhanced New Imager in extreme ultraviolet, will image the Earth's plasmasphere, which is the part of the magnetosphere where a lot of charged particles are trapped. From the L2 point, the spacecraft can see the entire plasmasphere, which allows them to get a global picture of how it behaves over time. Last but not least is the only instrument not named after a constellation, CLOTH, or Cislunar Object Detector within Thermal Insulation, which if you're looking at this whole time, it's a cloth, or more accurately, the thermal insulation. You can measure the amount of dust in the area by measuring how many collisions you have with the dust particles on the side of the spacecraft. I just love the simplicity of this instrument. But these CubeSats, along with all their friends, will make sure that Artemis I will provide a treasure trove of science. JAXA's contributions to the Artemis program don't end there. After the disastrous Constellation program, the Americans realized that doing everything by themselves really doesn't work. It's just too expensive, hence why they've enlisted the help of the European Space Agency, ESA, the Japan Aerospace Exploration Agency, JAXA, the Canadian Space Agency, CSA, and more. The most straightforward place for them to contribute to Artemis is the Lunar Gateway, a new space station to be placed in orbit around the Moon, consisting of 4 modules. The core of the station, the power and propulsion element, and the habitation and logistics outpost are provided by NASA, while the European system providing refueling, infrastructure and telecommunications is provided by ESA. The 4th and final module is IHAB, the International Habitat, thusly named to prevent the Americans from thinking they could do any of this without us. Trust me, they tried. Most of the module will be provided by ESA, though JAXA provides the environmental control and life support system. This system is set up in such a way that no resupply of water or oxygen is needed at all. CSA will provide the robotics interfaces to control, for example, Canadarm3, which they will also provide. JAXA's contributions to Gateway don't end there. Much like how they provide resupply missions to the ISS, JAXA will provide the HTV-X for resupply missions to the Gateway. I've made an entire video about this spacecraft, which I'll link in the icons and the description. In short, it's the next generation of HTV spacecraft. Cheaper, better, faster, stronger. On the ISS is the only way to deliver international standard payload racks, which primarily carry experiments. This won't be possible or necessary on the Gateway, as the Gateway variant, the HTV-XG, will use a docking port compatible with the International Docking System standard, which is smaller than the common berthing mechanism, but does allow for autonomous docking. JAXA won't just provide equipment for on-orbit operations, but also for surface operations, like the Lunar Cruiser, a large pressurized rover developed by JAXA and Toyota, which will allow for extended surface missions that may span several days. It doesn't appear to be finished yet, but official renders show it having turn signals. Why? Anyway, with an estimated delivery date of 2029, it won't be the first thing the Japanese will put on the surface for the Artemis Programme. That honour will belong to Heracles, a robotic lander developed by ESA, JAXA and CSA. Where the Japanese will provide the landing stage, the Europeans will provide the ascent stage, and the Canadians will provide a rover. They plan to use this for sample return missions as early as 2026. JAXA hopes to use the tech developed for the Heracles landing stage for an even larger lunar lander, capable of possibly carrying crew down to the surface, either on their own or in collaboration with ESA. In a similar vein, Heracles will use tech developed for SLIM, a small lunar lander set to launch very soon. This mission is the topic of my next video in my 3-part series on the Japanese moon missions. Until then, I'll see you next time.